Hello, welcome to the 10-8 notes where we are going to learn how to write equations of circles. So before we begin, we're just going to do a little bit of review from chapter 1, and that is the distance formula and the midpoint formula, because we are going to use those quite a bit in this section. So the first one is, given 2 points, the length of that segment, or the distance between those 2 points, is the difference of the x's. Doesn't matter which order I write them in. Square that, plus it's the difference between the y's, and square it. Likewise, or equivalently, this would equal, if I was to square both sides, I would get segment AB squared equals, squaring a square root is, those are inverse operations, so I would get rid of the square root sign on the right. And the midpoint formula is like finding the average, so it's the sum of the x's, x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, so now in the second part, we're going to apply the distance formula to determine the equation of a circle. Well, here we are given that the circle has a center of HK, so I'm going to go ahead and label that on my picture. And then it passes through a point XY. I could draw that anywhere I want along the circle. If you recall, the distance between the center of a circle and any point on that circle is called R. So we're going to apply what we did up here and write the equation of this circle. R squared is going to equal x minus h squared plus y minus k squared. So now we have a circle with center h comma k, and the radius is going to equal just r. Okay? And I could have done the distance formula where I would say r is equal to and then the square root and have to square both sides to get rid of the square root. But this is basically your important equation of a circle that we're going to be using throughout this section. All right, so now we are going to determine the center and radius of the circle, then we're going to graph it. So here, notice it's in reverse order, and typically it is going to be written with x and y on the left side, and then your radius squared is going to be the right side. So if it's x minus h squared, the center here, the center is going to be -1, comma, from the y I get +3. It's always the opposite of what was in the, or what is in the parentheses, because if you think about it, just to explain it, this had to have been x minus what number? -1 squared, plus, and then y minus 3 squared. So therefore h is -1, k is +3. The radius, again, we're going to take what the equation equals and square root that number. It is 5. When I go to graph it, I start by plotting the center, which is -1, +3, and then I have to count 5 units away from the center. Now, I can't count diagonally in a coordinate plane, but I can count up, down, left, and right. As long as I'm in a vertical or horizontal position, I can absolutely go 5. So 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 to the left, and then 1, 2, 3, 4, 5 down. Now when I draw this, and I think I just went 4 instead of 5. When I draw this, I do not want to draw it like this, because that does not look like a circle. So instead, and Notability will, if you're doing this on Notability, obviously they have the option or the ability to make the circle nice for you, but if not, you just want to go and just kind of make it nice rounded edges. Don't make it look like a diamond or a rhombus or a square. Okay, so here we're going to write the equation of a circle. It's given its center and given the radius. So the center is always your special h comma k. So it's going to be x minus 5 quantity squared plus y, and now if it's minus -4, it's going to become +4 quantity squared equals, the radius is 7, the equation is always equal to the radius squared, so 49. Okay, next one, the center is 3, 0, and the radius is 2 root 5. So when I write it, it's going to be x minus 3 quantity squared plus y minus 0 quantity squared equals 2 square roots of 5 squared. So now I'm going to clean this up. X minus 3 squared, I can't do anything with. I'm going to leave it. plus over here, I just write it as y squared. That minus 0 is not necessary. You don't have to write that. Now, I have to remember how to square 2 square roots of 5. So, if you remember from all our radical reviews that we've done this year, it's 2 root 5 times 2 root 5, giving me 4 times the square root of 25. Square root of 25 is just a weird way to write the number 5. So this ends up being 4 times 5, so it's going to equal 20. And if you could square that in your head, fantastic. When you have a radical inside the parentheses that's being squared, it's the outside number times itself. So 2 times 2 times, and then the 5 will get released because you're squaring it. All right, for number 3, we are given the center of the circle and a point that it passes through. So now you just have to be careful when you label these. The center is an ordered pair, but it's a special ordered pair. It has its own, it has its own special name, H comma K. Okay, so I'm just going to put a little HK over it. And then the point is just some arbitrary point. There's an infinite amount of points the circle goes through. So this is just one of those infinitely many points, 3, negative 5. So now all I'm going to do is plug into the formula that is just your generic circle formula. And the one and only thing I'm not going to know here is r squared. So when I plug in x, it's 3 minus h, which is 1. Square that, plus, and then y is negative 5 minus negative 2, square that. And this is going to equal r squared. So over here I get 2 squared, plus over here I'm going to get negative 3 squared because I would end up adding the 2, and that equals r squared. So 4 plus negative 3 squared is 9 is equal to r squared. I get 13 equal to r squared. Now that is not the equation of a circle, okay? That is just what r squared is. So now I have to go back and make sure I plug in these values. So my equation in the circle is x minus h, which is 1, squared, plus y plus 2 squared equals the whole thing I was looking for from the get-go, r squared, so it's 13. Notice that I'm not squaring it, because I already have r squared, and the equation is equal to r squared. All right, for number 4, I think it's a good idea to kind of, sketch the picture of this circle. So I have endpoints are the diameter 0, negative 6. Oops, sorry. Let me draw a coordinate plane here. 0, negative 6. And my other endpoint is 6, 1, 2, 3, 4, 5, 6, and negative 4 right there. Positive 6, negative 4. So if this is my diameter, clearly my circle looks something like that. Okay, not the greatest circle. Sorry about that. All right, so now I know that the 2 things I need to know about a circle to write its equation are its center, and I need to know its radius. Okay, I don't have either of those things right now. However, if these are the endpoints of the diameter, I could find the center. It's right in between the 2 of them, so I will do the midpoint formula. Okay, so that's going to be 0 plus 6 divided by 2. The 2 x's, add them up and divide by 2, and then add the y values, divide by 2. And so I'm going to get 6 divided by 2 is 3, negative 10 divided by 2 is negative 5. So this is my center, also known as HK, which hopefully you realize I need for the equation of the circle. So if that's my center, HK, this now becomes a problem like number 3 above, where I have the center and I have a point on the circle. In this case, I have 2 points on the circle, and I will use that to write the equation of the circle. So I pick either of the 2 points. Again, my equation is x minus h squared plus y minus k quantity squared equals the radius squared. I have 2 different xy's. I have this xy and I have this xy. Pick one, doesn't matter. I'm going to pick 6, negative 4. So I will get 6 minus h, which is 3, squared, plus y, which is negative 4, minus negative 5, the k value squared, equals r squared. And I see I forgot that squared here. Whoops. Don't make the same mistakes as me. All right, so now I'm going to clean this up. 6 minus 3 is 3 squared plus 1 squared equals r squared. So I get 9 plus 1, 10 is equal to r squared. This is not the equation of a circle. A lot of times kids stop there like, oh, that was a lot of work. I'm glad I'm done. No, if I asked you to graph that circle, you wouldn't be able to because it's not the equation of a circle. So therefore, I plug it back in using h, k, and r squared. So it's x minus h, which was 3 squared, plus y minus k, so plus 5 squared equals r squared, so 10. And that's me. Now moving on to number 5, we have the center. That's good. That's one of the 2 things we need. So I'm going to label that right away, HK. That's a special ordered pair. And now they're telling me that the circle is tangent to the y-axis. So if you remember from before we left school, if something is tangent to a circle, that's a line that intercepts the circle just at that one point. So here I'm at 3, -6. I lost count. Okay, so that's my center. It's tangent to the y-axis. Remember, this is the y-axis, so what that means is this circle will just intersect that y-axis one time right there. So therefore, I could count over from this point, which is 3, -6, to the point where it's tangent. It's got to be perpendicular, so it's going to go straight to the left. And this point is 0, -6. So what is the radius? How far is that? Well, my height is -6. That doesn't change. The radius here is that little horizontal segment, and its value is 3. So when I write my equation, x minus h squared plus y plus 6 squared equals the radius, which is 3, but then you square it, so you must put a 9 in the equation. All right, let's do number 6 over here. Find the center and radius of the circle. So now we're given the equation. We haven't had that in a while. Sorry, I don't know why this is being so strange. But we're going to find the center and radius of a circle, and they gave us the equations x squared plus y plus 6 squared equals 50. So the equation of a circle is x minus h quantity squared plus y minus k squared equals r squared. So looking at that, the center is going to be h is with x. There's nothing there. It's 0. And k had to have been -6 for that to be a plus 6 squared. So that's our center. Now here we see that the radius squared equals 50. So if I want just the radius, I square root both sides and I simplify the square root of 50. Perfect square inside of 50 is 25 times the square root of 2, giving me 5 square roots of 2. Okay, so that's my radius. That is my center. Number 7, totally different type of problem. We are determining if the given points are on, inside, or outside the given circle. So what we're going to do is plug in the x and y values in the ordered pair that they gave us. If it equals whatever is on the right side of the equation, so for number 7, for example, if it equals 36, it's on the circle. If it's less than the number on the right, it's inside the circle, and if it's greater than the number on the right side, r squared, then it's outside the circle because it's greater than the radius squared. Okay, so first one, 5 squared plus -3 squared has what relationship with 36? Well, 25 plus 9 is what compared to 36? Well, 25 plus 9 gives me 34. 34 is less than 36, so this value is smaller than the radius squared. So therefore, 5 -3 is inside the circle. Okay, part B. I am going to take -2 root 6 squared plus 4 squared and see what relationship does it have with 36. Okay, -2 times the square root of 6 squared is going to be -2 times -2, 4 times square root of 6 times square root of 6 is 36, plus 16 is what compared to 36. 4 times 6, 24, plus 16 is what compared to 36. We get 40. 40 is greater than 36, so therefore this point that they gave me is outside the circle because it's greater than the radius squared. And the last one, we have 2 root 2 squared plus 7, I'm plugging in x and y into the equation, minus 3 squared has what relationship with 24? 2 square roots of 2 squared. Square the outside number, you get 4 times the square root of 4, because you do root 2 times root 2, plus 4 squared is what compared to 24? 4 root 4 is 8 plus 16. This equals 24. So this point, 2 root 2, goes through the circle. So the circle, it's on the circle. The point is on the circle. All right, last problem, number 9, says, given the circle, x plus 4 squared plus y minus 3 squared equals 24, determine the following. The center, the radius, the x-intercepts, and the y-intercepts. So those two last ones are new. But the center here is going to be negative 4, comma, positive 3, right? Because it's h and k, and you take the opposites. The radius, this is r squared, so r is going to equal the square root of 24. I have to simplify that. Perfect square that goes in there is 4, so I could rewrite this as square root of 4 times square root of 6. So the radius is going to equal 2 root 6. All right, now for the new stuff. All right, so now we're going to look at the new stuff, the x and y intercepts. I'm not sure again why this is not scrolling all together, so I apologize that I have to like move it up in this way. But that's okay, we'll make do. All right, so anytime you're looking at any kind of graph, whether it's linear, quadratic, cubic, when you are finding x-intercepts, that is basically where your graph, whether it's a line or a parabola or a cubic, no matter what, the x-intercepts, the one thing that they have in common is you know that y is equal to 0 when you're finding them. So we are simply going to plug in 0 for y and solve for x. So we are going to leave x plus 4 squared plus, plugging in 0 for y, I'm going to get 0 minus 3 squared equals 24. So I end up with x plus 4 squared plus 9 equals 24. This point, it is a quadratic. Hopefully you guys see that this is one that I could square root because I have a binomial being squared. So I'm going to isolate that, the x plus 4 quantity squared. By subtracting 9 from both sides, I get 15 when I do that. And now I take the square root of both sides. I get x plus 4 equals plus or minus the square root of 15. Subtract 4 from both sides, it's negative 4 plus or minus the square root of 15. Should kind of make sense. If I have a circle, I'm going to have two different x-intercepts. Unless, of course, the circle was tangent to the x-axis. And now, similarly, when you're finding y-intercepts, a y-intercept is where whatever you have that you're looking at is crossing the y-axis. So in that case, x is 0. So I'm going to plug in 0 for x in my original equation of a circle. So 0 plus 4 squared plus y minus 3 squared equals 24. 16 is what I would get from the first parenthesis when I square it, plus y minus 3 squared equals 24. Isolate the binomial that's being squared, so I'm going to subtract 16 from both sides, giving me y minus 3 squared equals 8. Square root both sides. Y minus 3 is going to equal plus or minus the square root of 8. So now add 3 to both sides. Y is going to equal 3 plus or minus. Let's simplify the square root of 8. Hopefully I don't have to show that step. It's just 2 square roots of 2 because it's square root of 4 times the square root of 2. And those are my two y-intercepts. Okay, that is it for this video. Thank you for watching. Have a great day.